Hi grade 12s and welcome to question 7 of the May to June 2024 paper. So we're on 7.1 and 7.1 says, 6 years ago, Tabo bought a phone for 13,000 Rand. The value of the phone depreciated annually according to the reducing balance method. The value of the phone is now 8,337 Rand point 75 cents. Calculate the annual rate of depreciation. Okay, so you see they've already used a lot of keywords here. They've said that it's reducing balance, and they have also told us that this is depreciation. We're taking a phone that costs 13,000, that's how much we start with, and it depreciates to 8,000, okay? So we know this is a form of depreciation, but which type? Is it simple decay or compound decay? It would be compound decay. And the reason why is because they said reducing balance, okay? Reducing balance always stands for compound. So our equation would be A is equal to P bracket 1 minus I raised to the power of N. Okay, so that would be our equation. Okay, so let's think about what all of these are. So A, P, I, and N. Remember that they said that 6 years ago, right? They already gave us the amount of years, so we already know N is 6. 6 years ago, Tabo bought a phone for 13,000. So this is how much he starts off with this phone. Your starting amount is always your principal value. So that's the 13,000 that we have there. And then the amount that you end off with is your A value, and that's 8,337.75. So you see the difference with this one? With this one, with depreciation, you will notice that your starting value would be more than your ending value. And then, of course, we are actually looking for I, which they tell us is an annual rate of depreciation. So it's not compounded in any way. It's just an annual depreciation. Okay, so let's substitute. We're going to go ahead and say this is 8,337.75 is equal to 13,000. And then 1 minus our interest, we're looking for that, raised to the power of 6. Okay, so now that we have this equation, we have to get to I. Ask yourself, what is stopping me from getting to I right now? So I know there is a 6, yes, but that's not really the first problem. The first problem would be this 13,000 over here. This has to leave. Now, because 13,000 is being multiplied to this bracket, to get it out, we would have to divide by 13,000. So because this is an equation, what you do on the one side, you must also do on the other side as well. So this is what we have. Now, what I'm going to do is I'm not going to calculate this. I'm going to keep writing it like that so that I don't have to work with decimals. Okay, I want to avoid working with decimals. So that's what we have there. Is equal to, and so you see these would cancel and you'll be left with the 1 minus I raised to the power of 6. So you still want to get to the I. What is stopping you now from getting to the I? Now that would be the 6. So it's being raised to the power of 6. So to reverse that, or the opposite of that, would be to 6th root both sides. So we're just going to say the 6th root of this side and the 6th root of that side, of course, because it's an equation. So that 6th root and the power of 6 would cancel with each other, and then you just have 1 minus I, and then over here, you just have everything here. Okay, so here is something that we can do. I want you to notice that your I is actually negative. So what you can do to make this easier is take the I over to make it positive first of all. Then on the right-hand side, you're left with a 1. And then what we're going to do is take this over, and when you take it over, it becomes negative. So it's negative of the same number. Okay, so this is what we have. And then you can just put that on the calculator and it will give you your decimal answer. And so this is what we get. We get I is equal to 0.071352, right? But you need to multiply this by 100 because remember that they want the annual rate, okay? Rates are always in percentages. So we're going to say I is equal to, and just take your answer. So just say say equal to, then multiply by 100. Okay, so you see that it's 7.14%. And that is the annual rate of depreciation. Okay, moving on to the next question. Okay, 7.2 says, Eric and Tandy need to save 80,000 Rand to go on a holiday at the end of December 2027. So they tell us that Tandy decides that she will start saving at the end of January 2025. We'll keep that in mind. So Tandy's going to start at the end of January 2025. She will make 36 monthly deposits. Okay, they're making our lives easier. Make 36 monthly deposits into a savings account that pays interest at 8.6% per annum compounded monthly. Okay, so it's also compounded monthly. Let's just keep that in mind. The deposit will be at the end of each month. And that's fine. Then they tell us about Eric. Eric calculates that if he makes 48 deposits of 1,402.31 Rand, starting at the end of January 2024. Okay, she's starting 2025, he's starting 2024. He will have enough money to go on holiday. He will make his deposits into a savings account at the end of each month. Okay, that's just the same as her. The savings account pays interest at 8.6% per annum, compounded monthly. So same thing. So the question is, calculate the difference between the amount that Eric and Tandy will deposit into their respective savings accounts over the given period. So we're looking at the difference, meaning we're going to calculate how much they're going to deposit, not really their future value. We know how much they want to save. They want to save 80,000, but we're going to look at what they're each going to deposit, because just because you want to save 80,000, it doesn't mean that as a whole you would have deposited 80,000. Okay, future value has interest added, so you would definitely deposit less than 80,000, and then the interest will cover the rest. So we're really just going to work on this. We're going to work on both of their situations separately. So this will be Tandy, and let's work on Eric on this side. Okay, so let me just divide these. Okay, so let's start over with Tandy. We know that this is a savings plan, so we're going to, of course, use future value. Okay, we're going to use the future value formula, and it's best to actually just put that formula down so that you know what you're working with. So this is the future value formula, and we're just going to look at everything we need to have in these. So remember, the main goal is just to find out how much they're each going to deposit at the end of, this period that they have. So let's look at it like this. With Tandy, they said that Tandy starts, she's going to make 36 monthly deposits, and she starts at the end of January 2025, okay, which makes sense. So January 2025, and we know that she needs to end in December 2027. Okay, so as you can see, December 2027, if you calculate that, that is actually 36 months, because from January 2025 to December 2025, that's 12 months. Okay, so January to December of that, and then from, of course, January the next year to December of that same year would be 12 months, and then, of course, January 2027 to December 2027 would be 12 months again. So that is a total of 36. They made that easy for us so we don't have to overthink it. So we know it's 36 months, but then the thing about this is that we just need to look at a specific value. We need to know how much each of them are going to deposit as a whole. What tells you the amount that you're depositing is X. So let's actually make sure that we have X in each scenario. So in the first scenario, do we have the value of X, the amount that she keeps putting in to save every month at the end of the month, of course? Do we have that? No, we don't have that. They only told us about when she's going to start, the 36 months, that it was compounded monthly. They also told us the interest, but they didn't tell us anything about how much she's going to be paying every month. So clearly, we have to find that out with Tandy. So let's go ahead and do that. We're going to use the future value formula. So with the future value formula, we need the future value, which we know is 80,000. That's how much she expects to have in future. So 80,000 is equal to, we don't have her X amount, so we're going to hold on to that. And then we have bracket 1 plus, and our interest there is 8.6 per annum compounded monthly. Remember that 8.6% as a decimal is 0.086. Okay, so you just put a 0 in front of 8 because it's a single number. 8.6% as a decimal, that is 0.086 over 12. And then we're going to take that and raise it to the power of, now the N stands for the amount of deposits they're going to make. So the amount of deposits that she makes, since it's 36 monthly deposits, is 36, right? So we're going to put to the power of 36, then minus 1, all over our interest, which is of course 0.086 over 12. Okay, so we just need to solve for x. I want you to see it like this. You see all of these? They're just numbers. When you simplify them, it's just going to be a number. So what we need to do is get to the x. This number, okay, including the denominator, they're being multiplied, okay, to the x. So to get rid of it, you need to divide both sides by this number. So we're just taking this number and dividing by that on this side and on this side. So as you can see on this side, they would cancel. And then you would be left with, on this side, the 80,000 divided by that number. Okay, so it looks like this. And then when we put it on the calculator, this is what we're going to have. So on the calculator, as you can see, the answer that we get for x is 1,955.78 cents, rounded off to 2 decimal places. So now we have Tandi's x amount. Okay, and I'm not going to go looking for anything else because that's all they asked for. That's really what we're looking for. How much she's going to deposit as a whole. Okay, this is what she's going to put per month. Okay, so let's hold on to that. Then let's look at Eric. So with Eric, they tell us that Eric calculates that if he makes 48 deposits of this amount, okay, starting at the end of January 2024. So you see that with Eric, they already told us how much he's going to deposit each month. So that is the X amount. So Eric's X amount, we don't have to find that. That is 1,402 Rand 31 cents. Okay, so now that we have both their monthly deposits, we're going to find out how much they're going to deposit as a whole, individually. Okay, so Tandi is depositing for how long? For 36 months. So out of her pocket, what she's going to have paid, what she's going to have taken out of her pocket would be, we would take the amount that she's paying monthly. And how many months does she pay this for? She pays this for a total of 36 months. So we're going to multiply it by 36. And that's going to tell us the total amount that Tandi ended up paying. And when I calculate that, I get 70,408.08 cents. Okay, so that's how much Tandi pays as a whole. Now let's also go ahead and see Eric. How much does Eric pay? Well, this is the amount that he's paying per month. So we just have to take this and calculate, or not really calculate, they gave us that already, and just multiply by the amount of months that he pays this for. Well, Eric paid this for 48 months, okay? He made 48 deposits. So clearly he made more than her. He started earlier than her. And so let's see how much Eric pays. Okay, so this is how much he is going to pay. So that is 67,310.88 cents. Okay, so very interesting. Tandi started in 2025. Eric started in 2024. Okay, so he started earlier than her, and then he ends up depositing less than her when we look at it as a whole. Okay, that's obviously because the more time you spend to save, the more interest it's going to build up and help you reach your goal faster. So he wouldn't have needed to pay as much as her to reach the 80,000 because he started earlier than her. He started in January 2024. Okay, so that makes sense. But the question was, they want us to calculate the difference between the total amount that Eric and Tandi will deposit into their respective savings account over the given period. So just the difference. So as you can see, Tandi pays more. The difference between the amounts they pay is that 70,408.08 minus Eric's 67,310.88 cents. Okay, and the difference that we have there is 3,097.20 cents, really. Okay, so that is the difference. As you can see, Tandi ends up paying this amount more than Eric because she decided to start a little later. Okay, so that is that question 7.2. And then we move on to the last question in financial maths, 7.3. Okay, so we're finally on 7.3. And 7.3 says, Lesibana was granted a loan of 225,000 Rand. The rate of interest for the loan is 9% per annum compounded monthly. Lesibana will make monthly payments of 5,500 starting exactly 4 months after the loan was granted. How many payments will Lesibana make to settle the loan? Okay, so loans, it's already speaking about present value. So we just keep that in mind. It's going to be present value. And they tell us the loan amount already. So let me put down the present value formula so that we have it and we know what we're supposed to really look for. Okay, so this is the present value formula. And since they tell us this was the loan amount, right? That's going to be your present value. So present value is the 225,000 Rand. And then we have the rate of interest of the loan is 9% per annum compounded monthly. So we can already write that. I is going to be 9% is 0.09. Compounded monthly is over 12. And then they also tell us that Lesibana will make monthly payments of 5,500. So we have X is equal to 5,500 that we have there as well, because that's your monthly payments or your regular payments, right? Per month or per annum or every 6 months or quarters. So we have that and it is monthly payments. Then they say starting exactly 4 months. Okay, so that is a very big thing that we need to consider now. So starting exactly 4 months after the loan was granted. The question is, how many payments will Lesibana make to settle the loan? Okay, so we know we need to tell them how many payments at the end of the day. But here's this one thing we need to consider before even using this formula now. You see, these payments start 4 months after the loan was granted. So this is how present value and even future value works. This formula is adjusted so that when you are granted the loan, okay, so this is when you got the loan of 225,000, you are supposed to pay this loan. So here's the end period, whatever that is. Because this is a monthly payment, right? You're supposed to start paying this payment 1 month after. And the formula is already adjusted to be able to account for this, for that 1 month after. So that's where the person is supposed to start. But the issue here is that they don't actually start there. They start 4 months after. So you have to think about it like this. They're saying 4 months after as a whole, right? They're not even considering this 1 month. So we need to consider it. So if we're saying 4 months after, it means that here's where the loan was granted. It's 1, 2, 3, 4. So how many payments was actually delayed or missed? How many payments was missed? Because it's not really delayed, it just was missed as a whole. It was 3 payments that was missed. Now, there is a consequence for that. You miss 3 payments. What happens is the loan amount, how much you owed before, is not how much you're going to owe when you start paying. You're going to owe more, because what happens with that loan amount is you get charged interest on your loan. That's why when you take a loan from the bank, it is best to pay the loan as quickly as possible, because then you would pay less interest. However, people don't usually notice it because the loan time period will be like quite long. So you wouldn't even have noticed that you've paid the bank like so much money. In fact, before your loan is already done, like halfway through, you've already paid them their money back. And then now you're really just paying interest if you calculate what's going on. So we have to just account for this. Now, you see, this money is going to grow, but by how many months? It's going to grow by 3 months, because the formula is already adjusted so that you start paying 1 month later. So they can't charge you for that 1 month later, okay? Because that's supposed to happen normally already. They're only going to charge for that 3 months. That money is going to grow for an extra 3 months. So the first thing we need to do is take this money and actually grow it for 3 months. So that is A is equal to, and we're going to use the growth formula because we're trying to grow the money. So P bracket 1 plus I raised to the power of n. So let's find out what this is going to be. We'll take this amount and we're going to invest it for 3 months. So at that same interest, because it's in the same account. And so what we're going to have is 1 plus, and our interest is 0.09 over 12 raised to the power of 3. And I have to say times 12 because it's already in months. Okay, so let's go ahead and see what that gives us. Okay, so this is the amount that we get. A is equal to, it's quite long, so I'm going to take like 5 decimals just to be sure. I'll take 5 decimals. So that is 230,100 points, and I'll say 56367, and I think that should be fine, and it will not really affect the rounding. So what is owed right now is not this amount anymore. It's now this amount. Okay, that amount that we just got, that A amount, I'll just call it A. Okay, that's how much is owed now. And so that's going to be your present value. Okay, so that's what we had to consider. This is now the present value. Okay, so we're still using the present value formula. We have now accounted for the 3 months missed payments. So now that we have gone ahead and found out this amount, we can now find out how many payments, okay, in total, Lesibana is going to make to settle the loan. So let's go ahead and do that. So we're going to use the present value formula. Okay, so that's our present value is equal to, and the X amount, the monthly payment is 5,500, then 5,500, and then 1 minus 1 plus your interest. We have that, okay, 0.09 over 12 raised to the power of negative n, because that's what we don't have. N is the amount of payments. Okay, so I'm going to leave n as it is like that because n is going to be in months. You notice that when we're putting this formula down, right, we usually write the years, like if it was 5 years, then we'll say times 12. Is to convert it into months. So I'm not going to do anything to that. I'm going to leave it in months because the months will tell us how many deposits were made since these deposits are being made monthly. Okay, so I have that, and then close the bracket all over, and then it's going to be all over the interest that we have here. Okay, so we're just trying to find n. Let's see how we can do this. Because it's an exponent, there's a lot more we need to get rid of. So what I'm going to do is this. I'm going to go ahead and take 5,500 and divide it by this fraction. Okay, so let's divide that so that we can just get a number that we're going to put in front of the bracket. Okay, and I would rather leave this number as a fraction because as a decimal, you will lose some decimals, and that will probably be a problem later on. So what I'm saying is this is an entire fraction, but I'm deciding to divide this by this so that I can just put that number in front of the bracket. And so that number is 2, and then, oh, how many zeros are those? Okay, it's like 5 zeros. So 1, 2, 3, 4, 5 all over 3. Now it's not a problem because I'm going to get rid of this very soon. It's just to hold on to that, like to get that together. Then we still have exactly what we had in the bracket. So I'm really just going to take that and rewrite it again. Remember, in this part, you just have to be really careful in financial maths. Just make sure not to miswrite anything. And then this, of course, I'll leave it the same. I'm trying to stay safe by keeping it at 5 decimals, just so that, you know, nothing goes wrong. Okay, so this is what we have now. So at this point, what we can do is we're trying to get to the n. So since you want to get to this, what we can do is just go ahead and get rid of this number, because this number is the first thing that needs to leave so that you can get to the n. Okay, so how do you get rid of that number? Well, this number is being multiplied to this. So if you divide both sides by that number, you would get rid of it. So that means we should just take this and divide it by that number. Okay, so I'm going to do that. Okay, so this is what happens. You see, I took this number, and I divided it by that number over there because I'm dividing both sides. So here they cancel, and here, this is what we have, and I'm going to calculate what that is. So this is what we have on this side. Okay, I don't need a bracket there. Okay, so let's just see what this gives us. Okay, so the number I get as a fraction, it's really complicated. So as a decimal, it will be better to write. So always write it. If it's a simple fraction, you can just write it like that. If it's a fraction that is not complicated, So this is a decimal. I'm going to write as 0.3137734. Now I will just go dot dot, and I'm not really going to continue with that. I will just use this button ANS. That button is going to be very important in financial math always. And we're going to say this is equal to, and we have this still, and 0.09 over 12 raised to the power of negative n. Okay, so here, do you notice that this is actually negative? Because it has the n is also negative, but I'm just going to take that over. And so when it comes over, it now becomes positive 1 plus 0.09 over 12 raised to the power of negative n. So there's no negative in front of the bracket anymore. Then we still have this 1 here, and I'm going to take this number over. So it's minus that number, 3137734, and it keeps going. And so how I'm going to calculate that on the calculator is, I know that this has been recorded in this button ANS. So I'm going to press AC, clear that, and I'm going to say 1 minus ANS, because that's that number that was there. And this is what I get as a decimal. So rewrite this again, 1 plus 0.09 over 12 raised to the power of negative n is equal to, and we get 0.68626, and that just keeps going. Again, I know it's recorded in ANS, so I'll hold on to that. Now do you see where we are with this calculation? We are at a point where we have our exponent there, which is negative n, and we have a base and we have an answer. You have to just solve this. This is an exponential equation. So you need to use log, because these are complex numbers. They're not normal numbers that we can use here. So our exponent is negative n. That is going to be our subject now. And we'll say is equal to log, and the base number is going to be whatever was carrying the exponent, which is this. So I'll rewrite that as the base, 1 plus 0.09 over 12. And then here, I'm going to write that number, which I'm going to just write it as ANS so that it just makes it easier. Okay, so when I write this down, I'm going to say n is equal to, and you can press equal to, so that you have your answer. You would have already pressed equal to get your answer. Mine is a bit different. Then just press AC, and then you're going to go ahead and go to the log function that you need here. Log, and put down your base, which is this number over here. So we're going to say 1 plus 0.09 over 12, right? You can put brackets around it if you just feel like, it should be more protected. So I'm going to put brackets around that. And then here, I'm going to go ahead and say ANS, so that it doesn't cut out anything, and it's more likely to give you the correct answer. Okay. So press SD, because my calculator is, So we say negative 50.394. Okay. I just need the 2 decimals really. And it's negative, so you can just multiply both sides by -1 to make it positive. And now you know that positive n is equal to 50.39. Okay, so let's see what this means, right? Remember, we're just trying to find how many payments, was made to settle the loan. So you see that after we had considered the 3 months delayed payments, we finally got that n, which is the monthly deposits, is 50.39. So it means there needs to be 50.39 payments to settle this loan. But focus on their question. They want to know how many payments in total. 0.39 is not a payment. It's not a full payment yet. And that's the thing about it. Because it's not a complete payment, we cannot say, because we're just going to round down and say 50 payments. It can't be 50 payments. At 50 payments, you're not done paying this loan. There's still the 0.39 remaining. So because of that, the full amount of payment that you need to settle the loan would be 51 payments. So that's actually the answer here. It would be a total of 51 payments. Okay, so that is it for question 7. And then we move on to calculus, which is questions 8 to 10.